All right, Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are planning to start our new chapter, which is frames and machines. And the main chapter in which we're going to study is basically structural analysis of the R.C. Hibbeler, chapter 6. In this chapter, basically, we're going to study three types of different structures. Trusses, one of the structures that are basically is trusses, and if you look at it, this is going to be one of the parts of the structure. Other is frames, and the third one is machines. Okay, so if you can watch my previous videos, in those videos you can see that we have already studied trusses, doing an example of a truss using method of joints, and we also solved the same problem using a software called MDS, mechanical design of solids, in which we analyzed the same truss and we compared the results of the analytical calculation with the software. Now basically comes what we're going to study is frames and machines. Okay, so frames and machines are slightly different compared to trusses. The analytical study of trusses is comparatively easy compared to frames and machines. Okay, so if you look at it over here, basically frames are stationary members. They are basically been fixed, and they are multi-force members. Okay, they are different from trusses. Trusses also stationary, they are fixed, but trusses are not basically multi-force members. They are basically two force members. And they are basically, frames are basically multi-force members. This is a very important concept that you must take into account. Okay, so, and machines basically are moving multi-force members. Okay, so there is a difference between frames and machines and trusses. There is a very minute difference between the trusses and frames, but there is a very big difference between the frames and the machines. Okay, so frames, as I told you, are commonly used to support various external loads, and basically they are being connected together by means of sometimes pins. They can also be connected by these frames by glue, nails, bolts and rivets. Okay, and if you look, machines are basically they are contains moving parts which are being designed to transmit and alter the effect of forces. Okay, so this is a brief intro about the frames, machines and trusses. Okay, trusses are always two force members. Okay, the force will always be either tensile or compressive acting on them. Okay, two force members. So in order to properly analyze in order to properly design or size the structures, we need to perform force analysis. Okay, we need to find the magnitude of the force they sustain. Okay, the structure, because every such structure, as you know, basically is determined by means of an external load. It will, every structure, whichever we want to talk about, it will always have an external load. Okay, and if you have any what is called as a beam, which basically you will take, it will always have some sort of an external load acting on them. Okay, it will always have some sort of an external load. Okay, and if a machine is there, that load can be, in case of a machine, it could be altered. Okay, and this load, if you are studying solid mechanics, has the capability to basically also deform the structure. It can also basically deform the structure. Because of this load, there will be some sort of a deflection. Okay, remember this, there will be some sort of a deflection. So how would you define a frame? A frame is a structure. A precise definition of frame is, it's a structure that contains one or more three force or multi-force members. Typically a frame is fully fixed in space. Okay, this is a very important thing, that the frame is basically always it's always fixed in the space and uses a stationary arrangement of members with a goal of supporting forces that are applied to it. So this is the precise definition of a frame. How will you define machine? Machine is an arrangement of members where typically the members can have significant motion relative to one another. The usual goal of a machine is transmission of motion, okay, or basically you can also say they transmit motion or they alter, okay, transmission of motion or alter the vector of forces, okay. And very important, one question arises, why machines are studying in statics? This is the answer, okay. Here we will assume that the motion generated by machines does not have any inertial effect, okay. If it does have inertial effect, we will not study in statics, rather we will be studying it in dynamics. So this is a very important question, that why if we study machines in statics, the inertial effects will not be studied, okay, or basically because we will assume that the motion or the changes in the velocity are almost very slow, okay. This is where we assume there will be almost no change in the velocity, and when there is no change in the velocity, the acceleration will be zero, okay. So frames, machines, and very important concept, when we draw the FBD here, basically when we draw the FBD for frames and machines, it is helpful to identify the two force members and label their unknowns, okay. So we will study in the next few slides what basically are two force members, and they are very important when we are dealing with machines, okay. They are very important, they will make our calculation very easy when machine analysis are going to come, okay. So just a reminder, to increase your knowledge about trusses. So trusses are always supporting external loads. Every member of truss is stationary member and is assumed to be a two force member, okay. It will always be a two force member, okay. So whatever member we are basically talking about, it will always be a two force member. If you can see, this is your, if you can see, okay. So we will always assume, if any member is there, if we take this member over here, okay, this member over here, okay, we will assume that it is a, here we will assume that this member is going to be a two force member, which means, okay, so forces will be acting in this direction, okay. It can be either forces will be tensile, or we can also assume, or we can say forces could also be on this member, forces can also be compressive, okay. So here you say is tensile, and here you say compressive forces, okay. Every member of truss is stationary. Trusses are extensively used in the construction, okay. So they are being constructed basically in construction. They are used in roofs, bridges, communication towers, transmission towers, also known as, they are basically a simple version of frames, okay. They are not frames, but very simple, because their calculations are very easy compared to frames. So these are all, if you can see, this is a roof truss, this is if you look at it, this is a bridge truss, okay. This is basically a crane is being there, on which basically a truss is being installed. There's a big boom of the crane which is lifting the load, and again you can see this is basically a frame, and if you look, there is a machine installed by means of a pulley, and there is basically a chain is there, and then there is a pulley which is going to, and then there will be also a hook to lift the load, okay. So these are the telecommunication tower, okay. These are electrical towers. If you look, they are all made up of trusses. So trusses again is a very important member and very much used in the, if you look around, you will see their live examples all around. Frames are stationary structures composed of multi-force members, okay. This is a load bearing frame. These are two members, okay. It's a multi-force member. Chair, you look at bicycle frame, okay. Their forces are acting, many forces are acting at different orientations. Overhead crane frame to lift, especially used in lifting of the engine from a car, more majority of the times. A catapult frame, very old basically machine used in old wars, okay. You can see this, it's basically a very old machines. Lifting frame of a crane is there. This machine, this is again, if you look at it, this is a lathe machine, okay, in which you can basically build various machine components, okay, on a lathe. You can do turning, you can do chamfer, You can do a lot of operations. So this is a frame, and these are machines. Okay, machines, as you know, are structures composed of moving interconnected multi-force members transmit altered forces from one point to another for the purpose of reducing human effect. One of the main differences of machines is that they will, remember, always have some sort of a mechanical advantage. They will always have some sort of a mechanical advantage which you can calculate. They are basically helping a human effect, okay, reducing the human effects, and you can calculate the mechanical advantage. Okay, as you can see in this example, basically you can very easily calculate the mechanical advantage of this pulley. Okay, so a gear train is also a machine, pulley system, a can crusher, this construction machine, okay, your internal combustion engines, okay, your oil pumping machine, oil rig, okay, which is there, internal expanding brake mechanisms. We have a brake shoe, and basically hydraulic, and basically from the in the pipe you have basically a pressure transmitting pipes which are going to pressure the brake shoes, and they will touch along the drums and basically of your brake and stop the vehicle. Again, friction will be involved also. Okay, steering mechanism, car steering mechanism is also a machine system. Okay, now we go. So just to have a background knowledge further of this subject is that all these basically trusses are basically, whenever we analyze a truss, if whenever we be going to analyze a truss, okay, so we must remember that whenever we plot the free body diagram of joints, the internal forces at cuts will be axial forces. Okay, as I told you, they will be either under tension or compression. Okay, but that will not be the case for the case for the frames and machines. Okay, we have to basically here isolate the entire member and combination of the members from the structure. Okay, so we will analyze because there most of the times whenever a machine comes or a frame comes, they will be statically indeterminate. Okay, so when they are statically indeterminate, because there it means that there will be more unknowns, okay, than the equilibrium equations. We cannot solve them directly. Okay, we have to use different techniques for solving them. Okay, so this is the background. Then how do you analyze a frame or a machine? Okay, so basically we must always remember that we determine the load. Whenever a machine is there, we need to determine the loads at the joints and supports. Okay, for example, if you look at it, if you have any frame, okay, if you have any frame coming, okay, there is some sort of a load acting, and that frame on one side, if we have a pin, and if we can say on another side we can have a roller or a pin, and so basically we have to analyze these points. This is, we have to analyze this point, we have to analyze this point, and we have to analyze this point. Okay, so this is what it is saying. The frame forces acting at the joints and supports. Okay, this is going to be the joint. This is going to be the joint. What are forces acting at this point? And this is support. This is the support. Okay, and this is also the support. Is trying to say you. So if these the frames are properly constrained, here they are being constrained by a pin and a roller. Okay, this is your roller, and you can say this is your pin. Okay, if you look at it, the frame contains no more supports or members, not so that the structure may not become redundant. Okay, they are required to prevent collapse without redundancy. If these conditions are met by using the principle, the entire frame needs to be in equilibrium. Okay, very important. Then a very important equation that you must remember, okay, and that is to solve these frames and machines, we must always be able to solve it that the number of unknowns must be equals to the equations of equilibrium. So we have to make what does this means? It means that the case, it is an example of a statically indeterminate system. Sorry, statically determinate system. Okay. So this tells you that we can only analyze these frames and machines once it becomes a statically indeterminate system. Because otherwise we look at it, it will always be a statically indeterminate system. We want to make it a statically determinate system. So again, basically, here basically, if you look at it, these are the conditions. Whenever we analyze, how we going to analyze it, I'll show you the example which is coming after this. You need to basically isolate each part of the drawing, its outline shape. This is very important. You have to make sure you basically label, identify each known and unknown forces on this along with the specific coordinate system. Okay. And number two, you need to identify all the two force members in the structure and represent their free body diagram as having two equal but opposite collinear forces. Okay. And number three, if you look at it, he says forces common to any two contracting members act with equal magnitude but opposite strength on the respective member. So this is a very important point, and he tells you if the two members are treated as a system of connected members, then these forces are internal. Okay, so at the joints the forces are always going to be internal. So this theory we are going to do it when we solve the problem, we will apply these concepts. Okay. And again, remember that a couple moment is a free vector and can act at any point on the free body diagram. Okay. And force is a sliding vector. Okay. So from the principle of transmissibility, remember this thing, it will be sliding vector coming up from the principle of transmissibility. Okay. Transmissibility. So how we going to solve it? We will count the number of unknowns and compare it to the total number of equilibrium equations that are available. So in two dimensions, there are three equilibrium equations that can be written for each member. This is the technique we are going to use it. Okay. Then we will sum moments about a point that lies at the intersection of the line of action of as many of the unknown forces as possible. Okay, we are going to sum at a specific intersection where basically we can have when we take at the intersection of the line of action of as many as unknown forces as possible. This will help us make them unknown forces. This technique will help us make those unknown forces as zero because they will have no momentum. Okay, at that point we are going to taking the moment. If the solution of the force a couple moment magnitude is found to be negative, it means that the sense of force is the reverse. Again, since the direction of the forces and couple moment you can assume, and if you assume and the result is coming negative, it means that your assumed direction was wrong. You can the real direction was the opposite to that what it was. Okay, so just a reminder, force analysis in frame. Okay, if you have, this is a frame. Okay, this is a frame. It has two members. Okay, if you look at it, it has two members. So if you look at it, this is also a pin, this is also a pin. Okay, these are supports, and this is basically your joint. If you look at it, this is your joint, this is your support 1, this is your support 2. Okay, at A and B. So if you look at it, how are we going to solve this system? If you look, can we solve it directly? If you look, is there any way we can solve it directly? Because if you look, you can easily deduce here that there will be, since this is a pin, okay, you can have one reaction here, you will have one reaction here, you will have one reaction here. Okay, you can assume that, and also you can have you can also assume, just to understand it, Can we solve it directly? Let's see. One unknown here, because it is pin. We are assuming it as a pin joint, okay, and we are assuming it as a okay. So these are just our assumptions. Now see, if you look at it, how many unknowns do we have here? If you look at it, 1, 2, 3, 4, 5 and 6. 6 unknowns, 2 unknowns at the support, 2 unknowns at this support, and 2 unknowns at the joint. We assume P and Q are known, okay, P and Q are known, okay. So we say, for example, P, we can say P is equals to 100 Newton. We can say P is equal to 100 Newton. Q is equals to say 20 Newton, whatever it is. Okay. So now we cannot solve it because we have 3 equilibrium equations. Okay. If you look, how many equations of equilibrium we have here? Equations of equilibrium are 3. And if you look how many unknowns we have, how many unknowns is basically 2 plus 2, 2 plus 2 plus 2 equals to 6 unknowns. So you cannot solve it directly. So we will see some sort of a technique to solve it. So what we will do, we will try to basically separate this member AC and this member CB from this joint, this common joint. So when we do that, you can very easily say that this, again, just visualize this member. If you visualize this member, you will say that here it was a pin, so 2 reactions. Here is another pin, so we have 2 reactions, and this is basically force P, okay, acting over here. And then we have another joint over here. We will say that we'll separate it, and basically we will say this is CX and CY. But you look very important. Okay, this was just counting number of unknowns. So here we are basically saying this is the actual direction we assume, and here we also assume this is another basically direction we have assumed, CX and CY. Again, these are all assumptions. You can take the totally opposite to that. It is your choice. So once you have assumed this direction, when we go to this, okay, you can see since this common joint, it is an internal force and it has to be in equilibrium. The direction of Cx is opposite to minus Cx and the direction of Cy is opposite to minus Cy. So this is a very important point when you are doing frames and machine analysis, and at the joint you have to be very careful when you are doing joint analysis, pin joint analysis. Okay. So we will what we will do is basically we will try to calculate the unknowns basically at the supports, and then we will visualize, we will basically analyze member AC, and then we will analyze member CB, and we will apply 3 equations of equilibrium here. We will apply 3 equations of equilibrium here, and we will also apply 3 equations of equilibrium over here also. Okay. So basically we can to get the respective unknowns. Okay, we will see how we will do that. Okay, when the numerical is coming. Another, if you can, how it's a joint, a common joint is being shown you over here at A. So when you separate them in order to analyze the structure, you see this is the assumed direction. You are assumed direction. This is assumed direction. Okay. So but this is now mandatory direction. Okay, mandatory direction. Same with here, you have got a pin holding frame. Okay, so what you do, this is basically they are showing you what, a ball and socket joint, ball and socket joint. Okay, it has got 3 reactions. Okay, if you go to supports chapter table 5.2, it will tell you the ball and socket has got 3 reactions. Okay, but it will not prevent the rotations. So at this is we'll separate it at this between this A and this pen holder. Okay, so you can have 3 reactions. Again, if you say, you can assume these 3, assume You can assume this, but these directions are going to be mandatory. You cannot exactly the same. If you basically assume these directions wrong, and if you say, for example, if this is your ay direction, okay, if this is your ay direction and you say I want to have the same direction as ay like this, okay, then your numerical will be wrong. You will not be able to converge to the correct solution. This is a very important point. If this is the direction of ax, then for the other basically component of the frame, this is going to be the direction of ax. And if you add all those components, you add this ax with this ax, it will be 0, because this is going to be plus ax minus ax. If you add this ay with this ay, this is going to be one is positive component, negative, the result will be 0. So this is very important, and because in frame analysis are very typical, you must understand these points. If you understand these points, you will be very easily able to solve the frames and machines. Okay. So basically we'll stop here, and in the next chapter and the next part of the video we'll continue with the two force members. Okay, so thank you very much.